In Texas are working on some self-watering soil. It absorbs moisture out of the air using a special gel and then releases it later, stimulated by heat. We're joined now by Guihuai Yu, who is Associate Professor at the University of Texas in Austin. Thanks very much indeed for joining us, Professor. Tell us how this product works, please.
Sure. Thank you for having me, Andrew. So this self-watering soil is composed of the regular sandy soil and a special gel we call it super moisture absorbent gel. So basically it can pull water from the air and then distribute to the plants. And then the soil can harvest the moisture from the air and store the water in a humid and cold night. And under solar radiation and with warmer temperature, so the liquid water can be slowly released to irrigate. So it's really mimic what nature does. We want to learn from the nature.
I'm sure I've heard of products like this before, additives for soil to increase water retention. What's different about this gel?
So traditionally, the hydrogel has been used just for store the water. So you still need to start with the liquid water to put in. So the first irrigation still requires the water. But the SMAG, we call it super moisture absorbent gel, is very special because we don't need any of the water irrigation. So they will absorb the moisture with a high efficiency from the air. So basically, you don't require any of these water or like a power, the kind of complex these power lines. So it can self-water itself and self-sustaining.
What about the cost of this? How expensive would it be to do a large area? Have you managed to do any research into the expense here?
So currently, the two chemical ingredient that actually make the function of a self-watering soil. So one is for the moisture absorbing gel. So that actually is the not yet commercially available polymer. So the other part is we call it thermal responsive. Basically, it's under mild temperature heating. So they can actually release the water that you originally stored in the gel. So that part is actually less expensive. So right now we are trying to actually use more low-cost raw materials and then simplify the process to make these materials. And then actually with the help from the industry partner, so we are going to do more the field tests, so in various kind of conditions. And I think with the scale, the things from the industry help, they can become commercially available in the next few years.
So, I mean, obviously vast areas of the world are irrigated artificially now. I'm thinking about California, Texas, I'm sure as well. Lots of water is used. The idea here would be that no extra irrigation would be needed for arid land farming?
Yes, exactly. So as we know, the global warming really accelerates the climate change, and the Earth is growing warmer. So that actually plays this very large ecological stress on the ecosystem, including including agriculture, water management. So the ability to grow more crops from those previously poor quality or inhospitable lands become increasingly important. So as the world population continues to grow, so we wanted to bring this new perspective, a new technology to have increase the capacity of the agriculture.
What does the gel stay in the soil? Does it have to be refreshed or does it break down?
So in our test in the lab scale, so we actually test these SMAG soil over months. So we actually do not see any degradation of these special self-watering soil. But I think in the more conditioned field tests, if the hydrogel will not be degraded by bacteria, so that's actually will probably do not require of the replacement of the gel. So that actually requires further investigation. So we hope to have more comprehensive answers in a very near future.
What about areas, I'm thinking about sub-Saharan Africa, or areas that are being hurt by aridity, drought? Could this become a solution on a very large scale?
Yes, that's our hope. So we hope this technology can be a useful one for the health of the people and also for the health of planet. And then especially as the pandemic hit the world early this year, so the global food supply chain has been significantly disrupted. So many countries actually realize that they need to depend on their own to increase the food production. So I think this technology can be used for not only these arid conditions, but also generally can be useful for many kind of agricultural production increase.
I'm just curious, I know you are a materials and chemicals specialist, but have you had an opportunity to work, say, with fungus scientists? Obviously, fungus playing a huge role in soil health as well.
Yeah, that's exactly right. So we are right now collaborating with these plant scientists at UT Austin, and also we want to work with the industry kind of partner to actually doing more tests. And also in the near future, we want to also to see whether this special self-watering soil can enable the controlled release of the agrochemicals. So that actually will be very important to help alleviate these land degradation, because right now people overuse of many chemicals. So if we can use this special gel coated with on the soil and also release these agrochemical fertilizers slowly, so we don't need to overuse any of the chemicals. So that also is a potential benefit we hope to see.
That is fascinating stuff. Thank you very much indeed for joining us, Professor.
Thank you. Thank you so much.
Guihuai Yi is Associate Professor at the University of Texas in Austin.